If you have any questions, raise your hand and we'll give you a mic. You can also, if you wish, steer the conversation depending on what you want to say. Any question?
Hocam, TTO'muz yoğunluktan dolayı gelemedi ama o biraz önce bahsettiğiniz bilgilendirmeyi bir genel anlamda yapabiliriz aslında.
Tabii.
Hani ben TTO'da olmadığım için sadece akademik kısmında çok hakim değilim ama genel bilgi alırsak belki hani TTO'muzla görüşüp onları bir bilgilendirme şansımız olur.
Okay, so the question is currently no people from the
To start, what will you to do? To start, what will you to do? Maybe.
Well, we can do this kind of like all together, but I can start. So first of all, if we it depends how we find this technology. Sometimes the scientific experts are coming to us and telling like, hey, we have this kind of thing, what do you think about this? And then we usually assess the maturity of this technology. We check whether it's better to open source or patent. It depends on the value and which kind of a technology this is. And then we usually do a little bit market research. So who will be the users of this technological innovation, let's say. And then we have two different roles. So one is to put in our CVC, CERN-Türkiye, which is our startup venture program. Or then another one is to reach out to different companies who are manufacturing some of the technologies. Yes.
Our university is a touristic university about neuroscience. My friend yesterday tried to ask, but I think she will ask.
Can I give you the microphone?
Yeah, take it.
Please start again.
Maybe I should wait for my friend,
Okay.
because also she wants to listen about this question.
Right.
So I can ask later, okay?
Sure.
If I may compliment maybe what Nora was saying, we have essentially four ways of collaborating, four kind of major contract. One is a consultancy. So you come, you have a problem, and you want to have some, let's say, some consultancy on your problem, how we can resolve it, and so on. Another way of collaborating is working together is the licensing. So we have a product that is ready to go. You want to get it, we provide you a license. Doesn't necessarily mean money, but a formal contract of licensing. Okay. A third way is collaboration. Collaboration means that we make something, we do something, and then you make something in exchange. So this would be really a collaboration between us. This is normally more suitable for research institution or non-profit organization, but not always, not always. And then there is a fourth that is a research contract. But the research contract is a little bit special. It doesn't really cover. Okay, it can cover, but it's limited covering in the knowledge transfer activity. So it's some institute that come and ask us to make a research for them. That should be in a domain, our domain of activity, which is a little bit specific. So these are the four kind of formal contract that we can establish with companies or with other organizations.
In that regard, can I ask a question related to some of the products or procedures you mentioned yesterday in your talk, like caffeine, for example? There is an ongoing already project or a program with contributions from European countries. So how a company, let's say from Turkey, can join this ongoing project already in terms of licensing or in terms of using this technology here in Turkey for a product?
Okay, in the specific case, the partners I've shown, most of them, not all, but are partners that belong to European collaboration, European project. And then when a project, European project already started, you can always join as an observer, but you cannot participate really to sharing, for example, the money afterward. We provide the technology, okay? Then the field of application depends on the customer. And in this specific case, we have most of medical institutes that want to use this technology, for example, for stroke prevention, not only stroke prevention, but in stroke prevention there is transplant, liver transplant, but the other application. But if a company comes with a concrete use case, for example, logistics, where you want to apply this system in logistics, we can discuss and we can collaborate. Also participating to existing project is possible, but as I say, if the project is a European project, it doesn't belong to us the decision, you know.
Any question?
Hello, I am Sartaj. I'm working here in the Department of the Basic Sciences. So actually we tried to build a detector to monitoring nuclear reactor. For that reason, we needed a gadolinium-loaded plastic scintillator. I searched Elgen, Saint-Gobain, and no one produced gadolinium-loaded plastic scintillator, and we started producing our own scintillator, and we managed. Then I started to build up a company to produce the plastic scintillator, and just we sold one plastic scintillator so far, and it was good time. We also published the result, light yield, the other things, also gadolinium plastic scintillator sample publication accepted. So we are going fine, but since we don't have regular income, we are going down faster and faster to that valley. And we decided to shut down the company. But we have the know-how, but we don't know how to sell a product. Because I am a scientist, so I don't have any money to buy a seller or this kind of things. So if I were you, what would you do, or what would your future path in the future? I mean, you have know-how, you have scientific knowledge, but just you are a scientist.
Join the team.
the question, I mean, thank you for sharing. In our group there is a team of people who is there to help startups. So we are not the experts, but we do have quite a lot of knowledge, and we can put people in contact with the relevant experts. So we don't have an incubator at CERN, but we network with incubators in the member states, and we have a network of people who can help. But when I hear your story, I wonder, is there a market? Because you might not be, you are a scientist, and maybe you could turn into a very good businessman, but the issue is there a market for what the company was selling? And was the business plan good enough? Because if you have a very interesting product, but the only customer is one detector at CERN every 30 years, then you can be the best businessman in the world, and the company will necessarily struggle. So, but in general, what we look at is the business plan. Okay? So have you identified a market? Because there is a real need in the market for what you're selling. And then if the business plan is solid, you can find investors. And if you don't find investors, that's a sign that maybe your business plan is not solid enough, and maybe it's not your fault. And then, of course, indeed, there are scientists who prefer to stay scientists, and then the venture capitalists might help in finding management team, etc. But it all starts from having a solid business plan, which might not necessarily depend on you. If you, in our fields, we do things which are so specific that sometimes the only market you have is high-energy physics, and high-energy physics is not a very good market to be in because it is often not very large quantities, not very often. If you would you have a startup which wants to sell very high field magnets for the FCC, they might struggle. There might be a market within 20 years or limited periods. So that's a little bit the issue we see in physics, that if the market is, and this happens to us, okay? So sometimes we have startups and we realize that actually it's a startup made by people from CERN, and the idea is they have is to sell something to CERN. And this is difficult because depending, of course, if it is informatics, it might be a bit easier, okay? But if it is about detectors and accelerators, the needs of CERN are not necessarily good enough to sustain a good business model. I don't know if I answered your question.
Yeah. Thank you.
Any other question? Yeah.
Maybe you can also look to other markets that you have not explored, because sometimes we as scientists, we focus more on what we have and the standard application of our technology. Recently discussing with some friends working in another organization, the nuclear fusion organization, they told me that most of the companies today are working in the nuclear fusion will probably disappear in a few years if they don't start applying the technology that they are developing for nuclear fusion, that maybe will be ready in 50 years or 30 years to other domains. So the company that will survive are the company that takes the technology that they are developing in such a direction and start to make pocket money, let's call it pocket money, on other field of application. In the meanwhile that the technology evolved to be applied for research. That's a suggestion.
Yeah, also for this chart, because it's a detector, so detectors are used, for example, in the medical devices. So how I would like to always check all the novel innovations is kind of like thinking it as a patent application. Because every time, I don't know if you have ever seen one or done one or something, but then you're discussing with the lawyers and they are turning everything upside down. They are checking every single road where this innovation could be used. So this is also a really good method for to do a business plan and checking all the use cases, and then checking the markets and kind of like creating the list of possible uses and possible use cases, and then checking what is the current status, the state of art, let's say detectors in this case.
Where is the mic?
Hi. As a company, we produce composites, polypropylene and polyethylene includes copper alloy powders, and we use it for example, the healthcare, the helmet, for example, or so for example, someone's broke his arm and for cover. We made its antibacterial and antiviral testing and its success, and we produce 3D printed filaments, but we couldn't success to printing. I think this material is very good for using. For example, I taught a couple of healthcare, for example, the hospitals, whatever. They said, okay, it's good, because they are buying the polypropylene and polyethylene plastics. They make a high pressure, and after that they use. But if we use this filament for 3D printing, we can produce personal dimensions for everyone. Maybe I couldn't explain, but it's quite technical for me. Maybe we can talk later too.
Sorry, we can say it again. We can produce
3D printed filament.
Okay.
And these filaments, polypropylene and polyethylene, main base, and it includes copper alloy powder.
Okay.
Because of the copper's antibacterial properties. and it's really a success. We made in Istanbul Technical University, testing, biomedical part. So it's success. It's totally antibacterial and antiviral. But we couldn't use this filament in 3D printing. We tried maybe hundreds of tests, but we couldn't, it's not sticking, we couldn't make the layers. Probably if the polypropylene and copper alloys melting point or something like that. And you said yesterday we are doing 3D, we have 3D, so maybe we can talk later on.
Yeah. But in this case, I think Giovanni is a case of specific case of consultancy.
I think so. Indeed, I think it's good if you, write me an email with what you just said, and then with Alessandro, because there is a team, is in Europe, right?
So in mechanical group we have 3D printers, but really we use it as a support for the workshop to print, to quickly print tools. Let's say everything that maybe in the past we did in aluminum machine, and now is printed because it's cheaper, it's faster to make tools and support for machines. So really easy stuff. But we are not developing really a technology there. So we are really using even some standard 3D plastic printer. Maybe we have done some research in printing some very hard plastic because we want to really use it to make functional components. And then we have a metallic machine, SLM machine. But there is another group at CERN, the Polymer Lab, which is in the market group. And they are much more experienced in printing plastics. And in any case, if you really have a problem of, let's say, of material science where you need to understand.
I think, so I'm not sure we have an answer, but it would be good to look into this, because also at a certain moment the Katie Fund is supported a project on 3D printing with copper. And I don't have, I don't have the answer in my head, but if you get in touch with me, we together can talk to all the people internally we have been doing with 3D printing, and then we see whether they have an idea of how to help. But this is an interesting topic, so it's a good example.
I can share the data and the problems with the pictures and data. You can check it. Maybe we can find a solution together.
Because this for me is a good example, because you have a concrete problem. I'm not sure we have the answer, but at least we have experts at CERN. We have been playing with 3D printing, and then we can see, and there are two things which can happen. Actually, three. One is they say, we know how to do it. That's rare. But the second is we have no idea and we cannot help. And the third one is we don't know, but maybe we have some ideas, we can work together, because this could actually be also interesting for us at CERN. So those are the three. Now, I cannot tell you which one of the three will happen, but it looks an interesting problem, concrete and related to some knowledge that we might have. So.
As an engineer, I prefer the third one, but as a company, I prefer the first one. I don't.
Yeah, but no,
good,
interesting topic.
And in this case, you can end up as a consultancy, let's say, contract with CERN, or both.
Or a collaboration, exactly. So imagine. Indeed, if imagine we had the answer. Imagine that our experts say, oh no, but we understand why, and we can tell you, etc. And these are simple consultants.
Probably first I will share data with you. You will check, and after that you will decide this.
Yeah, absolutely, exactly. Thank you.
Anybody else?
I have two type of question I want to ask first. It's about, yesterday we talked about energy efficiency. Since I heard about this 80 petabytes data which you obtain from every experiment, I was thinking about if we reduce this data from the experiment, my idea, I don't know, is it possible, because my friend is professional about electronics, but I'm a physicist. Can we make blind the detectors or some microchips, microelectronics, to certain energies which we want to filter? We will already filter it. We have a lot of data from the experiment, but we have also unuseful data, right? So we have to filter it, and we have to use AI, and we have to consume a lot of energy for this. So why we don't take this data at the beginning? If we filter these unuseful energy levels, so we already obtain a filtered data, and we don't have to use more energy for this. Is it possible?
I think we can certain so I can partially answer. Well, first, I think let me make a statement. We would like to consume as little energy as possible. Okay? So we are not there just wasting energy because we like.
Yeah, I know.
No, just because it costs money. It's not good for the environment, so we look into this. But if you, I start answering in the detector, because this is the part I know the best. So the issue is, first of all, there is, even from a technical point of view, we really try to dissipate as little energy as possible. Why is that? Because for a physicist, the ideal detector is something which is made of nothing. Because so we have the particles which are created by the collision that we need to detect, and therefore we need to put something on their trajectory to see them, to detect them, but this something disturbs the trajectory of the particle. So for a physicist, the ideal detector is something which is made of no matter whatsoever, right? Which does not exist. But we try
for example, calorimeters, they are measuring the energies, and they are collecting the energies. Maybe we filter this energy before get them electric signals.
So
maybe I couldn't explain what I mean exactly.
What I wanted to say is that the reason why I was talking about the detectors and why for us it's good not to dissipate energy in the detector is because you need to cool it. And cooling means that you need to bring into the detector some coolant, which is matter, which is serves the physics. So that's why we really try to dissipate as little energy as possible. Now, why do we dissipate energy? Because this filtering, which we already do, is necessary because we need to send out, and this is because also storing data then is expensive in terms of energy. And that's why we send out as few events as possible, and we throw away all the rest. Now, the calorimetry, the measuring the energy of the particle is necessary to understand them. So all parts of the detectors, you have the tracker at the beginning, and then you have, so the detectors are, if I oversimplify, there are parts which measure the trajectory, because from the trajectory of the particle you can understand the momentum and the energy, and then you measure the energy also through the calorimeter. So this part is essential because, we don't see the particles. So to understand what happens under the collision, you need to measure all these things of the particles. So I'm not sure how we could do it differently, if I may. But maybe I have not fully understood your idea.
Yeah, maybe I couldn't explain fully, but how I say, I know how detectors work, and I know about calorimeters, and I know we have many particles after the collision, but some of them, they are already known. We don't have to discover again. So if we filter this before the detection, or we detect already because exists, when we detect it, we don't want to make it data. just in the beginning.
I understand. I understood now your idea. I mean, my understanding, but maybe we need to count. But my understanding is that indeed many of the events we produce are not interesting. But the triggering, the filtering in the detector is composed of several levels, and they need information from the calorimeters to understand. So, for example, in the inner tracker, we store everything, waiting for the information for the calorimeters to tell us whether what we stored internally temporarily is interesting or not, and then we send out all the data which are of interest. So, I think, in my opinion, what you're implying is already happening, which means that as we most of the time produce things which are not interesting for the physics because we know them already, we send out only the data about the events which are of interest. So I was saying yesterday, and also the Sun was saying, out of the 1 billion collision per second, we send out the data of about 1/200. So there is already a lot of heavy filtering, and the information from all the sub-detectors are used to do this filtering, which is made of it's called trigger, and it's made of 3 levels of trigger. And so all the sub-detectors in the detector contribute to understand and identify the 100 or 200 events out of 1 billion that we want to send out, and all the rest are thrown away. But it is, I mean, if I understood well your idea, it could be avoided to send some particles to the calorimeters because we don't want to know about those. But these you will know after you have done it. So the fact of sending those to the calorimeters is part of the filtering process.
Okay.
Yeah, I didn't convince you. I can see that. That's good. We can continue the discussion.
But in fact, to say that a particle is not interesting, you have to measure the characteristic of the particle first to say this is not a particle I want. And to see the characteristic of the particle essentially that you expect are the charge, the mass, and the energy. So to identify this, you have to look at, let's say, how the particle travel inside the detector, not to identify the mass and the energy and the charge. So you have to reconstruct the particle to say, okay, this particle I don't need. You cannot put, it's not only a filter that you put on energy, or a filter that you put on the curvature of the particle, or a filter that you put, there are multiple parameters, so you cannot filter just by one. This is why you have to acquire everything, and then as a first filter, the first trigger, that is close to the experiment, really close, then you filter all the particles that you don't need. But you cannot avoid to acquire the information. Because not only one information. You have to remove a particle getting maybe 3 information concerning the particle. And so you say, this is not a particle I want, so you remove it.
But it might very well be that you have a great idea in mind and we don't understand it. So still, if you want, write me an email and I put you in contact with the people in the experiment which know more than we do, and maybe we can continue the discussion. Indeed, I mean, our feeling here is that this part of detecting everything, at least to start with, is a necessary part of the filtering to identify the events that we want to really keep. And because we do store only very few events out of all the ones we do. The other thing is that I don't have the numbers, but my feeling is that most of the energy we dissipate at CERN goes into the accelerator. I'm not sure the detectors really contribute a lot to the total consumption of the laboratory. I think that the really energy-consuming part is the accelerator, but I cannot tell you how much is 90%, 10%.
But what is important what you say, in the sense that also talking about the accelerator is superconducting. So we try to save as much as energy as possible because we cool down the accelerator to the temperature that is practically the temperature that 0 Kelvin. Okay, 2 Kelvin in reality, but doesn't matter. So we cool it down and then we use superconductor. This to avoid to dissipate energy. So this we are doing already what we can. I imagine that an accelerator like ours, without superconductivity, could not be affordable in terms of consumption.
And the other question, maybe my friend also will ask about it. our university especially focus on neuroscience and try to understand human brain, and of course early prediction is already heard about the disease. Which technologies in CERN we combine the neuroscience? Of course, we try to examine your page, but if you have an idea, which technology can combine with neuroscience?
Yeah. We are working with neuroscientists in various hospitals. First are this European project we mentioned before, where we try to predict the recurrence of stroke, in stroke of various patients, and this collaboration with various hospitals. So our idea is to try to predict the recurrence of a secondary stroke. Try to understand how we can release a patient from the hospital in the best way possible. Today there is a protocol, and everybody is fit in a let's say somehow in a protocol, and then is followed. Now we try to personalize this to every patient. Then there is another collaboration that we started recently to map this stroke evolution in brain thanks to graph neural network. So we try to, we would like, let's say, we would like to predict exactly where the stroke in the Brodmann area starts developing, to be able to help the stroke unit to act in the right way to save the patient, especially question of time, for question of. We have another project that recently yesterday called Biodynamo that started looking at the evolution of the Alzheimer, understanding how each neuron grows and how these neurons interact with each other. So this is a sort of simulation environment where you try to reproduce the evolution of a patient with Alzheimer, the evolution of the brain of a patient with Alzheimer, to try to understand what was causing, how has evolved, why has evolved in this way. So it was really a research project to understand something that today is not well understood. So essentially, my knowledge, maybe there are other, we have digital technology we use a lot for, at least recently we have these 2-3 projects that are rising with various hospitals and stroke units. We focalized on stroke simply because the first project was on stroke, and then the second project went to stroke. Then we have pattern on stroke, but we can apply in any other domain. So stroke is just, as I told you before, is a use case that comes from the field, and we reply to the needs. But there are surely other direction on neuroscience we can work with.
Yeah, we have a lot of devices, for example, measuring the low currents, which is useful, for example, in the brain analysis, anything related to magnetic fields or low currents, like, for example, related to TMS. I guess you are familiar with. So some specialties in CERN exist also in these fields. If you have any specific ideas or questions or ways to measure something, you can always reach out and send an email, and we try to search, for example, a group which is specialized in some measurement technique.
Especially, I want to search about radiation effects to brain. Maybe we can talk about later which. I will prepare a project. Which technology I can use for it? Of course, medical imaging technologies we already use, but something else you can offer.
So let's say, neuroscience is very wide, and we don't do neuroscience as a CERN. So one way of doing this it would be that you list what are the things that you need, that you know more than we do. Okay? So for example, you just mentioned radiation effects. Okay, and then what comes to my mind is that we have at CERN a lot of radiation facilities. And actually, some of them are used by people doing studies of biology. So we cannot irradiate animals at CERN, etc., but tissues or things like this, yes. And so, for example, we have a project where we are studying how to use very high energy electrons to treat cancer. And there are people from a university hospital who study the effects of radiation on tissues, human tissues, who come to us with zebrafish eggs or other non-animals to test under radiation. Okay? So this might be, for example, one possibility. But to answer your question, if you ask us which technology can you use in neuroscience, when I feel like I answer with a question saying, well, what do you need? Because I'm not a neuroscientist, so I know our technology well, but what I was saying also yesterday might be more difficult for me to tell you which of our technology you can use, rather than for you to tell us, I want to study this, I know what I want to do, but to study that, I would need this. So for example, if you want to study radiation effect, which radiation? Okay? Tell me what the radiation you need, and then I can tell you, or maybe yes, we can do tests of CERN because we have a plethora of radiation facilities. So my two indications, because I think your question is interesting, you say, how do we start a collaboration? So we came to Istanbul for 3 days, and now everybody's saying, okay, how can we do something together? Okay, which is what we want, that's why we are here, and what I hope some of you also want. And there is no one recipe only, okay? So my recommendation would be that you go through all the value proposition. It doesn't take long, okay? But yesterday we showed this material, and this is really, in my opinion, good material, because in a lot of the contacts we have after an event like this comes because companies go through this material and say, okay, now I find, because I say this is the most efficient way. If it is you telling us what you need, rather than us trying to guess in your field that we don't know what you might use, that's very difficult. Okay? And I know that sometimes it happens, but most of the time it works well. Technology transfer in general, in my opinion, works well when it's a company or a research institution who comes and say, we need this and you might have it, can we work with it? So my recommendation would be that you have a look at all the value propositions and you try to see whether you find a link, and if not, then also send us more information about the research you want to do and what do you need to do, because that's what we need to know. Okay? So it's also for companies. The request before was something we can work on, because we say we did this, we did that, and now we want to do it 3D printed, but it doesn't work. We don't quite know. Maybe it's the temperature, etc. So this is specific enough for us to say, okay, I understand your issue. You have a need. You specify it's pretty technical, and we can work on that. And you should try to do the same, which I know is complicated. But it's for us to say which of our technology can use in neuroscience. Of course, Alessandro has some ideas, etc. But it's, you see?
I already realized that my question became complex because I'm a physicist and my colleagues from neuroscience and biology, and I'm alone here. So I am trying to ask everything together because I want to search about this. Also, my colleagues, a research group, searching about brain. So I was trying to ask everything together. So it became complex. But I understand that I have to be specific about my question.
Yeah, because we cannot do it for you because we are not the experts. And so you need your colleagues, which are biologists, neurosciences, they know the field. And what we will need is that they say, okay, we want to do the research, which we understand mostly nothing about, okay? But to do what we want to do, we have these specific needs, and that's what we can work with, the needs that we have. And then we can try to understand how we can do this matching between what we eventually have to offer or not, and what we need.
How they did it's like website on KT is available, and you will find all the information over there. And usually what happens is that I think Eczacıbaşı had a contact with KT, for example. They had some. You remember I had a contact with you and we asked you a chip or something about it, but it was in the development and it wasn't final yet. So the company goes through the KT website. Actually, they did a research over the internet and they found CERN had something that they may use, etc. And then they contacted him, me first, and then I got Giovanni, get with them, and we got the information. So probably your colleagues and you can take a look at the website and see if any technology or applications over there, if any one of them may fit your needs. If they do, then you can contact KT and see how you can utilize that technology.
Yeah, this is a good example of what I can mention. So this company needed to measure very small currents, and we have a technology which can measure very small currents. So when they saw that, they say, "Oh, that's interesting. That's exactly what we need." So, but we're happy to think along. So if you send me more information about your research, of course, the more specific you are, the easier it is for us. But you know, it's always interesting, and we can. What we do, I mean, sometimes we have the answer ourselves. Sometimes we involve our technical experts, you know, and I think we could send it to our usual suspects, colleagues in CERN, which are already working on medical projects, etc., and then we can see if somebody has a good idea.
I think that, if really we don't find anything inside the organization, let's say we have a big network, so maybe we can put you in contact with someone that has knowledge outside the organization. This is sort of transfer technology between member states and not through, but through us. Okay, if it's really something that we don't understand, it's something that we don't know.
They have a big network.
So not only that you give the informational help, but you also facilitate any interaction as well. That's, I think, very important part.
You know, it's science, it's something maybe interesting, so even if it doesn't bring us anything directly, it will be a curiosity for us to try to sort out the problem, if we can.
It's true what Alessandro says, this is the fourth pillar of CERN, collaboration. Okay? It is, indeed, CERN can act as a connector sometimes. You know, that we maybe don't get involved, but if we know other people, then we can put contacts, and this is part of the mission of the organization also.
Yeah, this is the partnership, because CERN belongs to everyone, all of us, in that sense. So yes. Shortly, let me.
Hello, I am Adem. I have a question for Alessandro the second. Alessandro the Great.
For the Greek.
Alessandro Magno.
Alessandro the Great, okay. Is there any ongoing project about additive manufacturing, especially metal additive manufacturing in CERN?
Well, I was telling you yesterday, we are on the business of metal additive manufacturing since I think 10 years. So we are not really, let's say, we are not the expert in this domain. So we wanted to acquire this technology. So we bought a machine.
SLM, right?
SLM machine. So now I think after 10 years we managed, let's say, I don't want to say that we master the technology, but we managed to, we have printed many parts, especially specific ones that are fits this type of technology. But what we try to do is to print new material. So to use a standard machine without any development and try to print new material. And for us, well, we try with copper, even if it's very, very difficult for technical reasons. And one material that we were able to print was niobium, that is interesting for us for the superconducting property. And the printing of niobium, let's say, we solved some challenges. One is to have a good powder, because niobium, when you make it in powder, is very sensitive to oxidation. So then, let's say, you can print it, but you lose completely the superconducting properties that we need. So first of all, it was to find a supplier of powder sufficiently pure and let's say clean and well conserved to avoid oxidation. And then we were able to print, and the other, let's say the other domain of development was find a good thermal treatment process that makes the printed component really suitable from the point of view of superconducting properties. Because you, let's say, what you obtain after printing has not the parameters that we need to use it for the purpose we need. Let's say there is one parameter is called RRR, that is both for copper and for niobium, and is a particular parameter that gives you the performance of the material when you put it at cryogenic temperature, and it makes it superconductive in this specific case, the niobium. So this is one type of research, and the other type of research is we would like to print, for example, stainless steel or aluminium. But then we want to use the printed component for ultra-high vacuum purpose. So it's a component that needs to be used in an ultra-high vacuum environment. And again, in this case, if you just print it like that, the surface finishing, the porosity are not really suitable for ultra-high vacuum application. So we developed some post-processing to additive manufacturing, essentially again, thermal treatment, surface finishing, and we were able to obtain components that are currently used in one of our accelerators that are ultra vacuum compatible. That's the small development that we did in this domain.
I understand from your saying you're open to collaboration.
Of course.
I took your card. And
yeah, I've seen.
I will send. Okay.
I've seen your mails.
Thank you.
Shortly, let me switch to Turkish. Biliyorsunuz bugün bu oturumda böyle paralelleri ve birebirleri yapmayı planladık. Geniş bir katılım olur ve 4'e böleriz şeklinde. Ama sanırım dünün üzerine bugün genel soru cevap da aslında verimli oldu. Az bir katılım var. Daha büyük bir şans sizler için şu anda. Hani daha kalabalık katılım olmasından belki. Dün 4 tane konuşmaydı ama birçok konuyu kavradı bu şeyler, konuşmalar, teknolojileri ve biraz da hani iz düşümünde olabilecek uygulamaların etkisini veren. Eğer genel daha fazla bir tartışma ya da görüşme şu anda gerektiren bir şey varsa biraz daha edelim isterseniz ya da her konuşmacının hangi alanda zaten bilgi aktardığına artık hakimsiniz. Çok büyük bir organizasyona gerek olmadan hani birebir de görüşerek daha to the point almak istediğiniz bilgi, sormak istediğiniz soru hani ya da hani hedef CERN'ün know-how'unu ve mevcut teknolojisini olduğu gibi olmasa da sizin ihtiyacınıza göre nasıl yönlendirebilirler, nasıl destek olabilirleri tartışabileceğiniz bir versiyona geçelim diye öneriyorum. Okay. okey mi herkes için? Hani farklı bir görüş varsa devam edebiliriz. Yok sanırım. O zaman önerim şu olacak. 4 konuğumuzun hangisiyle böyle bir birebir görüşmeyi yapmak istiyorsanız, yani böyle bir ortam olursa birebir görüşmek istiyorum bir kişiyle ya da 4'üyle de ayrı ayrı diyenler kimler, bir el görebilir miyim? Hani organizasyon için çok fazla değiliz galiba. Yani birebir görüşme yapmak istediği husus olan sadece 4-5 misafirimizi ben sayabildim. O zaman hani bu oturumu, bu çalıştay kıvamındaki hani 2 tane program vardı aslında, birazcık ikisi karışmış gibi oldu aslında, iç içe oldu, mide oldu. Bu birebir görüşmelere peki kimlerle mesela görüşmek istiyorsunuz? El kaldıranlardan söyleyebilirseniz hangi misafirinizle? Hakan Bey. Tamam. Evet. Ve Nora'yla, okey. Tamam. Giovanni'yle. Tamam. Başka kim var? Böyle açıldığım birisi yok. Değil mi? Buna geçmeden önce devam edebiliriz tartışmaya. Yani şu andaki aktarmak istediğiniz, sormak istediğiniz başka husus var mı? Hani oturumu da kapatıyor olabiliriz. O yüzden soruyorum tekrar. Çok sık böyle bir imkan olmadığı için de hani aklınızda ne varsa, açıklığa kavuşmak istediğiniz, duymak isteyeceğiniz ne varsa lütfen çekinmeden onu paylaşın. Sanırım yok. Okay, well, we had just a discussion whether to continue as such or have a one-on-one contacts with each of you. There are a few in the audience who wish to do that. Maybe we can now swap to such a stage and we can end this session. Normally in the end of the program there was a concluding session with some remarks. What I just addressed, I think, was already including these concluding remarks. I believe what is from now on very important and critical that if everybody is aware of the KT website, the database, how to reach the technology lists, applications, mappings, and how to go in detail, and not to hesitate to contact either to really get help or transfer from the KT group at CERN or to ask for their help to facilitate any further interaction with any other partner working with CERN. These are all doable and we have these opportunities. Let's exploit them. Yes. And yeah, let me repeat. Hakan Bey de hani benle doğrudan temas ederek de tüm teması sağlayabilir herkes diyor. O yüzden I thank everyone for attending, spending their time with us today. I hope it was a fruitful event. So we officially can close the general sitting and we can ask whoever is interested to have a chat on one-on-one to meet with our colleagues. So thank you and we are
so we are closing, this is formal closing.
This we do as
so I just also want to say on our behalf, thank you very much for the hospitality. The event was great. We're very happy to be here. And indeed, we are, the key message, as Sarkan said, is we are very happy to keep on talking after this event. Keep Hakan in the loop, because I think we also want to understand in the future what has happened thanks to the event, so that we have a little bit of follow-up and it's done also on your side. But thanks a lot for welcoming us here. It was great, as usual. Thanks to you. Thanks.
Evet, o zaman görüşme yapmak isteyen arkadaşları alalım. There are like 4 or 5 people who want to either here or there. We have 2 or 3 rooms. Here.
lütfen uygun olan kişilerle sizler buluşup görüşmelerinizi yapın.
Do I distribute numbers? Do I distribute numbers? So one,
Priority lane.
she's the first one. Then
First come, first served.
Hocam,